I'm very proud of my ESP32 Wi-Fi real-time clock project. It uses Wi-Fi to connect to an NTP server to get the local time, then displays that to an LCD display. It works great, but it's a bit bulky. I wanted to miniaturize it, so I ordered some ESP32 C3 Supermini boards from AliExpress. This smaller microcontroller should fit onto the acrylic frame of the LCD display, making a clock with a much smaller footprint. Unfortunately, when I plugged this board into Arduino IDE, it didn't show up on the COM port list. So, is he dead on arrival or just shy? Let's find out. So here he is, an ESP32 C3 Supermini microcontroller board. I paid just $2.45 Australian for him. That price has soared to $3.85 when I was making this video, so I got a good deal. Or did I? Buying cheap on AliExpress does come with risk. Many cheaper clone board manufacturers have quality control that's, let's say, aspirational rather than effective. This is a HW466AB clone Supermini board, as you can see from the silk screen. The GPIO pins, voltage outputs and ground are also quite clearly labelled. So let's see what the problem is. This is a USB Type-C board, and if I connect it to my computer, this is what happens. The power light comes on, and the onboard LED starts blinking. Looks promising, right? But here's the stumbling block. If I set Arduino IDE to ESP32C3 and check out the COM ports, the board doesn't register. The power light means it's getting power, and the blinking LED seems to indicate the board is running, but I can't connect or upload any code to it. The blink code sketch is often set at the factory as a test. I'll spare you the 2 days of farting around trying to access the board. The seller suggested pressing the boot and reset buttons to trigger download mode. I also tested various voltages on pins while it was running, but no dice. ChatGPT and I eventually diagnosed that the onboard USB chip was probably faulty, or had been disabled at the factory. Chips destined for Internet of Things applications often have the USB chip disabled to avoid hacking. But that doesn't mean all is lost. Turns out you can buy an external USB chip. This USB to TTL serial board handles the communication between the ESP32 and the computer. Ironically, this interface adapter board cost more than the cheap ESP32, but I ordered one. This one uses a CP2102 chip, but others work with CH340 chips. These are the same USB interface chips you find built into the ESP boards themselves if they have one. The USB-to-Serial module also supplies 5V and 3.3V power. The Supermini needs 3.3 volts, both for power and logic level, so use that. 5V would probably fry it. The serial interface uses the RX and TX pins, with the RX of the adapter board connecting to the TX of the ESP32, and the TX to the ESP's RX pin. There was no documentation on the seller's listing information, but this pinout diagram I found suggested I try pins 20 and 21. That turned out to be good advice. It also shows the pins for 3.3V and ground. We'll need those to power the ESP32. I suspected I might have to do this for all the AliExpress boards I bought, so I made a little jig on a mini breadboard. I stuck the USB-to-Serial TTL interface to the breadboard with double-sided tape and set up jumpers for the correct pins. This way I just have to drop in an ES32 board and it all lines up. Let's give it a try. So, we connect the USB port on the serial board to the computer. This will supply the ESP32 with power and handles communication back and forth. Hopefully the ESP32 will now show up on a COM port, with the serial board subbing in for the broken onboard USB chip. And there it is. Choosing either the UART port or the USB modem option here will let us send data to the ESP32. The correct board is selected, and now we have the ESP32 visible on a COM port. let's send some code. While the code is compiling, we need to manually put the board in download mode. This involves holding down the boot button and pressing the reset button. Note the blinking light stops. The code stops running and the board is now ready to receive a new sketch. Arduino IDE gives you feedback, and you can see the connection being established and the code being delivered to the ESP32. There it is complete, but there's one more step. The ESP32 needs to be manually restarted using the reset button before the new code will run. I think this is a clone board issue, but easy enough to do once you know it's required. I probably should have downloaded something other than the Blink sketch, but you get the idea. We can now send whatever code we like to this board, but we'll need the USB-to-Serial board each time. So, was buying cheap ESP32s from AliExpress worth it? I ended up buying several different USB TTL boards to try out. These cost more than I'd saved on the cheap ESP32s. The whole process of diagnosing and solving the issue also tied up several days. But I ended up a lot smarter, and I have the interface boards and my nice jig to use if I need them again. And the mini ESP32s will work for my small footprint real-time clock project. If you just want something that'll probably work straight out of the box, go for a reputable seller online like Lonely Binary or Core Electronics. Links in the descriptions below. But if you accept the risk and are willing to do some legwork on the bleeding edge of hobby electronics, the AliExpress boards are cheap. I count the extra time and cost to be worth it for the education. The satisfaction of beating back the frontiers of my own ignorance are part of the fun for me. But I'm weird like that. I hope you enjoyed this video and learned something from my fumblings. Thanks for watching. See you next time. Oh, P.S. The next AliExpress ESP32 board worked fine first time. 6 more to test. I wonder what the hit rate's going to be. Wish me luck.